Hi everyone. Today we're going to be going through lesson 13.4, which is going to be dealing with graphing piecewise functions. So yesterday you learned what a piecewise function is and how to start graphing them, and today we're just going to continue on with that topic. So question number 1 says we have an office supply store. A customer, if they purchase fewer than 10 pencils, the cost of each pencil is $1.75. So I'm just going to highlight that. Actually, give me 1 second. My highlighter is out of battery. Okay, so let's continue reading. If a customer purchases 10 or more pencils, the cost of each pencil is $1.25. So they're basically saying here, if you buy more, it's going to be a little bit cheaper when you buy in bulk. C is going to be the function for which C of x is the cost of purchasing x pencils, and x is a whole number, which means, again, we wouldn't be able to buy half a pencil or 3.25 pencils. We are buying 1 pencil, 2 pencils, 3 pencils, and so on. So our domain is made up of whole numbers, and our range is the cost of those pencils. Okay, so if we take a look at this piecewise function, when it told us that if a customer purchases fewer than 10 pencils, the cost is going to be $1.75. The way this is going to look like in my piecewise function is here's my 1.75x from 0 to 9. So the second we buy 10 pencils, we actually get out of this piece of our function and we go to the next piece, which tells us if a customer purchases 10 or more pencils, the cost of each pencil now will be $1.25. So that's the second piece when my domain is 10 or more. So the first thing you're going to do is you're going to type into your y1 1.75x, and you're going to make a table from 0 to 9, or you're going to look at your calculator and you're just going to plot those points. But I'm going to write them out for you since we're doing this together. So 0, 0 is going to be the first point I plot, 1, 1.75, 2, 3.5, 3, 5.25, 4, 7, 5, 8.75, 6, 10.5. We get to 7. The price is up at 12.25. 8 is 14. And 9 pencils is going to cost us $15.75. So we could start plotting that. Again, just looking at my axes, each box represents 1. So some of these points we're plotting are going to be approximate. So let's start with 0, 0, 1, 1.75, so I'll go somewhere a little below 2, 2, 3.5, between 3 and 4, 3, 5.25, so a little bit above 5, and so on. I'm just going to keep plotting each of these points. 4, 7 is a nice whole point. 5, 8.75, 6, 10.5, 7 is 12.25, 8 is 8.14, and 9 is 15.75. Okay, so that's the first piece of our function. That's our 1.75x from a domain between 0 and 9. Now you can either erase what you have in there or go into your y2. I'm just going to retype this in now, 1.25x, but I'm only now making a table of values from 10 or more. So I'm just going to go from 10 to 16 because that's as far as my domain goes, is up to 16. Okay, so now I have the point 10, 12.5, 11, 13.75, 12, 15, 13, 16.25, 14, 17.5, 15, 18.75, and 16, 20. Okay, so 10 and 12.5. So that's going to get me all the way down here. Then 11 and 13.75, a little below 14. 12 comma 15, 13 comma 16.25, 14 comma 17.5, 18.75, and 16 comma 20. Okay, so we were asked to graph C, which is this function, on the axis below. Now, some of you might automatically, now that we've plotted all our points, go to connect these points, but since x is a whole number, it wouldn't make sense to connect between 0 and 1, or between 1 and 2, or 2 and 3, because that would actually indicate that there are domain values that are not whole numbers, right? So if I went and graphed between 0 and 1, right? Now I'm saying that there's all of these x values, maybe 0.5 or 0.25 or 0.75 or 0.4, that exist in my function, but they don't because my function only deals with whole numbers of pencils. So this is what we actually call a discrete graph. And I'm going to just bring you back to when we studied sequences. Sequences were similar to this in their graph, because when we graphed sequences, the domain of a sequence is just based on the position of a term, and we didn't have positions that were partial numbers, that were non-whole numbers. So position would be you're the first in line, the second in line, it's the third term, the fourth term. So there was never a value between whole numbers in the domain. So this is an example of that. Now, there is a follow-up question here. So a customer brings 8 pencils to the cashier. The cashier suggests that the total cost to purchase 10 pencils would be less expensive. State whether the cashier is correct or incorrect and justify your answer. So again, justify means we have to show some math. Okay, so we're going to go buy 8 pencils. So let's just think about where that is, right here. If you bring 8 pencils up, you're buying less than 10. So that would be that first part of the function, and that's going to cost them $14. Now, the cashier says if you buy 10, it's actually going to be less expensive. So now let's look at 10. If we buy 10, cashier is right, because 10 is only going to cost $12.50. So it pays to buy in bulk here. So the cashier is correct. And I'm just going to use the values I just found on my either my table or my graph to justify this. The cashier is correct. 8 pencils will cost $14, but 10 pencils will only cost $12.50. Okay. Now let's take a look at another piecewise question. So which graph represents this piecewise function? So the first piece here is an absolute value, and it says it's going to be an absolute value wherever x is less than 1. So let's just think about that for a second. Absolute value functions, we graphed them at the beginning of this unit. The parent function looks something like this. It was just a v. So think about where 1 is on the x-axis. We're only going to be seeing this part of it because it's when x is less than 1, which means to the left of 1. Then the second piece here is a square root function, and that's when x is greater than or equal to 1. So let's just think about that for a second. We graphed absolute value and square root functions at the beginning of this unit. Square root functions looked something like that. That's the parent function. So if this is where 1 is, we're only going to see from here over. So we're basically looking to take these two pieces and bring them together. So the left side of this graph is going to resemble the absolute value, and the right side of this graph should be resembling the square root function. So I see at least choices 1 and 2 have what looks like an absolute value on the left. But then if I look at the right side of both of these graphs, this choice here, that does not look like the square root function, right? That goes up more maybe like a quadratic or another type of absolute value. But if I look at choice 2, which is the answer, I can see this piece here resembles the square root function, and this piece here is my absolute value. Now, if you wanted to look at this, you could also type this into your y1, this into your y2. Now, it's not going to give you the piecewise, but it's going to give you the full two graphs, and you can just then envision if at 1 you only saw the left side of the absolute value and the right side of the square root function, which picture best models that, and it would be choice 2. Okay, and then for the last question we're going to do together, we're going to do one more graph. This question, not like question 1 where we had to think about a word problem and a model behind it. We're just going to look at graphing. So what I want everyone to do right now is take out your calculator. We have 2 pieces here. So the first piece, we're going to type into our y equals the absolute value of x. So I want to remind all of you that where you find the absolute value of x is alpha, window, enter. So alpha, window, and the reason I said enter is because it's choice 1 and it says A, B, S, and that stands for absolute value. Okay, so we're going to type in the absolute value of x, and we're going to list a table of values right now from -3 to 1. So while you're looking in your calculator, I'm going to write myself a table. -3, -2, -1, 0, and 1. Okay. So at -3, we have the value for y of +3, -2 is +2, -1 is +1, 0, 0, and 1, 1. And then I want to make one more note. This point here is a closed circle because it is including greater than, right? X is greater than or equal to -3, but this value is going to be an open circle at 1 because it is just less than 1. It is not equal to. So I'm going to make that note here. This is going to be a closed circle point, and this is going to be an open circle point. So we're going to see part of an absolute value function on this piecewise, but we're only going to see closed on the left side of it and open on the right side. So I'm going to plot these points, -3, 3, -2, 2, -1, 1, 0, 0, and then an open circle at 1, 1. That was not, I have the nice iPad that lets me make these straight lines. You do the best you can, or you use a ruler. Okay, so that's the first piece of our graph. Then the second piece, and you can use your calculator if you want, but we're looking at the equation y equals 4. So let's just remember for a minute, when you don't have an x and you just have a y equals, this is a constant line. For y. And if you remember, when we studied this way back when, these are horizontal lines. That's when y does not change its value. So if I was just looking at the line y equals 4, I would be looking at this whole line here, y equals 4, because that's where y is 4 always. And it would be arrows on both ends. That's the line, y equals 4. But that's not what we're looking for, right? We're only looking at this line over this domain from 1 to 8. Now, what's nice here, since they're both end equal to, I don't have to worry about open and closed circles. They're both going to be closed circles. Both ends are closed circles. So let's start plotting. All of these y values are going to be 4. And again, if you typed this into your y equals and you looked at your table of values from 1 to 8, you can absolutely do that. I'm not going to write all the points out, but you're just going to keep getting 4 because this is a constant line at 4, meaning it's going to go horizontal and the y value will remain constant at that value of 4. So I'm going to plot my first point, second point, 2, 3, 4, 5, 6, 7, 8. If you didn't plot every point, that's completely fine because this line is going to remain horizontal. So even if you just plotted the point 1, 4 and 8, 4 and connected them, that would be completely correct. So that is a complete piecewise function of that f of x, the absolute value of x from -3 inclusive to 1 non-inclusive, and then 4 from 1 to 8 both included. Okay, so I hope this was helpful. We reviewed what you did yesterday, which was just kind of introducing what a piecewise function is. It's pieces of functions over specific domains. And what you're going to do now to practice is there's an 11 question matching. So let me just explain how you're going to do this. This would have been a scavenger hunt if we had been in school, so that's why there's these little pictures, but the pictures right now are just there for your viewing pleasure. You don't need to do anything with them, except, look at them. But you have 11 equations here, all different piecewise functions with different domains. And then if you keep going in your notes, you're going to see 11 different graphs. So it's really up to you. What I would probably do is start with the equations, think about the graph, and then you're going to match them. So you're going to look at equation 1, all the equations then are being matched up with letters since each graph has a letter, A through K. Okay, so you're going to do this matching practice on your own. If you need to rewind and look through any of the video, you can. You have your calculators, so you can absolutely type these functions into your calculator. Remember, since they're piecewise, you're typing one piece in at a time, or you can type them into y1 and y2, and then just make sure you're looking at that specific domain. And if you have any questions, please don't hesitate to reach out to us, and we hope you have a great day.